Welcome back, great learners. So there is a jam question before me, and the other question is bonus anyways. So a boy observes a piece of stone at the bottom of a river 6.0 meters deep. If he looks from the surface of the river, what is the apparent distance of the stone from him? Now this is a jam question. Jam is always very funny while setting their question, but I love it anyway. So we'll talk about it. But anyways, number 2 says find the critical angle of a medium of refractive index 1.65. So we're going to solve this one later, but let's deal with the jam question first. So if you observe, whenever you are asked to look for apparent distance or apparent depth or apparent velocity or apparent anything, there is a formula that relates apparent with real and the refractive index. So the refractive index is going to be real depth. So since we are using distance here, this is going to be real distance all over what? Apparent distance. So that's what we're going to be looking for now. Apparent what? Distance. So they say a boy observes a piece of stone at the bottom of a river. So it has a real depth or real distance of 6.0 meters. Now, how do you get refractive index? It is a standard. Some standards are meant to be known. If you are truly ready for JAM, you should know some standards. The constant for refractive index of water is 1.33. You should know this. Don't allow anybody to keep you back. So just know it, right? All right, so if this is known and this is known, we'll just substitute it into this equation to get the apparent distance. But first, we have to make the apparent distance subject of the formula, or you can use any method anyway. I can just do substitution straight away. So 1.33, I can put that here, is equals to real depth 6.0 divided by the apparent depth. So this is the apparent depth. Call it apparent distance here. Now, if you want to make the apparent distance the subject of the formula, then we have to cross multiply. Yep. So cross multiplying, we'll have this over 1, right? So this apparent distance will multiply 1.33. So we have apparent distance times 1.33 is equals to 6.0. But we are only looking for apparent distance, so we also have to do what divide both sides by 1.33. So if we have apparent distance, will then be equals to what? 6.0 divided by 1.33. So let's find out that value. So we have 6 divided by 1.33. So our answer is going to give us 4.51. So apparent distance is going to be equals to 4.5 to the nearest decimal, right? 4.5 meters. That's our apparent depth. Yes. Then let's work out the second question. The second question says we should find the critical angle of a medium of refractive index 1.65. Now, same refractive index. Refractive index have a relationship. This is 2, this is 1. Have a relationship with critical angle in this form. So the refractive index is going to be 1 over sine of the critical angle. That's a very, very wonderful relationship that they have there. So if you substitute values now, refractive index is 1.6, so we have 1.65, and it's equals to 1 over sine c. Now if we do same thing we did here, this over 1 will cross multiply, so sine c will be multiplying 1.65 and it's equals to 1, right? So since we are looking for c, we have to eliminate what is standing with anything related to it. So we'll be having 1 over 1.65, right? So let's divide 1 divided by 1.65. We're going to be having 0.60606. Wow, what a unique number till infinity. And then sine c is going to be 0.60606. If I continue like that, that's how the number is. It's very unique number. I love it. All right, so we are looking for c. Since we are looking for c, we divide both sides by sine, so it's going to be arc sine of 0.6060, right? So c will give you, so let's find the sine inverse of that. Sine inverse of 0.6060 will give you 37.3 degrees. So whenever you have a medium in which the refractive index is 1.65, the critical angle is going to be 37.3 degrees. All right, thank you for following me in this solution. I'll see you in the next video. Bye for now.